Hi, welcome to Unit 3, Differentiation and Science, and the lecture part 2. This part of the lecture, the aim is twofold. So number one, we're going to review the science article, the only one for this week's reading, to introduce methods of promoting student learning and science using differentiated instruction. And then two, we're going to explore two examples of differentiating science with educations within two different education settings. Both of the examples are fairly good. So just before we get started, I wanted to show you the article, which is really short, and that was intentional. It's only 3 pages, Differentiation in Science Classroom, an overview of strategies to aid in general science instruction. So one of the cool things about us as educators is that we love to advocate and help each other out. So these overviews of strategies, if you read them very carefully, they serve as a summation of a lot of the current studies that are out there. So feel free to explore in-depthly and then take a look at the resources that are available to you, because honestly a lot of them kind of survey a lot of the research out there that is relevant to the experience. So as usual, I kind of loop around all of the article, but please make sure, especially if you are a science teacher, that you actually explore the whole thing. The other thing is, this week I included a plethora of resources. There are 2 of them that I thought could be very useful. Science Differentiation in Action actually looks at adopting learning practices for diverse needs and disabilities in this specific content areas. So I thought this was a really great resource because I know as educators we're always looking for the how of what we're required to do, and it's not always evident as to how to do it. And then this one is pretty neat because it offers a breakdown of differentiation for science, and I didn't have this be the focus text because of the fact that it starts off with summarizing some of Tomlinson's work, and then some other writers who have talked about differentiation and how to implement it, and then it goes into the examples of what it should look like. So if you are a science teacher or not, and you just like the way that the science content area research studies have used differentiation, make sure you take a look at the actual chart. What does it look like for science? Because it shows which strategy you could use, and then also the focus of differentiation that they're aiming to achieve, and then it provides a definition and some examples. So this is pretty cool. So this is another must-have. All right, so let's get started with the article. The quote that really struck me was this one. One could argue that the hardest part about science is reading the material, which I strongly agree. It says here, the vocabulary within the text is difficult. There are many graphs, pictures, equations, diagrams, and tables of information, all added to enhance the text, but can be overwhelming. So one of the things I think as educators we forget is that science really is about reading. I mean, if you're not able to read, then it's going to be super hard for you to actually analyze, to conceptualize, to really understand what you're being required to know in a science class. And I think that oftentimes we forget how important it is for students to be able to comprehend the basics, which is, what is this even saying? What are you asking me to know? And this goes into their actual comprehension of what the words mean. So it's very important that we focus in on the science component of it, because of the fact that the words actually, their inability or ability to comprehend the vocabulary within a science course dictates their progression through an actual lesson or a science experiment or lab work. So I think it's a little different. I think science and math both have this challenge versus with sociology and maybe even English courses that students can bypass they can navigate around the complex or the harder vocabulary. They can kind of maneuver, use some of their past skills and then study. But sometimes some of the things within science are foreign to students. So it's very important that we learn how to accommodate, not necessarily modify what students need to learn in order to make sure we're addressing their individual needs. So I wanted to talk about, I thought it was very cool how they talked about bridging the gap, the reading gap, by differentiating between accommodations and modifications, which while I was reading it, I thought, this is interesting, because I think a lot of us tend to go on the side of modifications, which is very different from what students actually need. So here they talk about the fact that accommodations means that it's a change in the way a lesson is instructed to all individuals in a classroom. And it does not require an IEP or 504, and it also doesn't lessen the level of rigor that is required for each of the students. What it does is it ensures that all students are being held to the same educational standard, but in the method that suits their learning preference. Versus a modification, which is literally you altering the curriculum for the required IEP specifications or 504 plans that students have. Why does this matter? Because all students should have the accommodation of vocabulary layering, meaning that you as an educator should come into the environment thinking that I need to differentiate the vocabulary, I need to differentiate the labs, I need to differentiate the students' accessibility to the content in a way that levels the playing field, meaning that everyone should come into your class and be able to be as successful as they desire within that science class, because you have engineered the things that they need within the structure of that lesson from different approaches. It doesn't mean that you're lowering the standard. It doesn't mean that you're changing the expectation of what is supposed to be learned. It does mean that you're equaling the playing field. And that's why differentiation is so important, because if it's used correctly, it does that. So here they talk about how to promote student learning of science. To be able to use certain strategies to promote student learning of science concepts from the text, Mason and Hayden recommend the use of text illustrations, creation of representational illustrations, imagery, and adjunct aids, along with text enhancements. The following practices are suggested for effective instruction. So that includes scaffolded and segmented lessons, moving students from simple concrete text to complex abstract text, which is huge, right? Because if they are not able to grasp the simple parts of the actual vocabulary of a particular lesson that leads into a lab, then they can't go into the concrete and the complex abstracts, which everyone knows that science vocabulary is very layered. So you need to address the layers individually and then collectively show students what the main task is. Number 2, organize, focus, and appropriately pace lessons. So the pacing sometimes is off with science classes. It doesn't allow for the different, the varied, approaches that students need to get to the level of understanding the complex terms and skills that they are required. Then it also says review of prior skills and knowledge, which I think is kind of a challenge, especially with the intense pace of a science class. I've seen some of the content curriculum from teams I've been a part of, and they have a lot of things that they're required to do, but you can't forget to allow students to revisit what they already know, and also decipher how the terms relate from other content areas to science. So sometimes students get tripped up off of same words that don't have the same meanings in different contexts. Number 4, goal setting, which is always important in any differentiated setting, but also any education setting. 5, teacher-led modeling. by thinking out loud the complete process for applying this strategy to reading science text. So I think this is important because this may help students kind of visualize what they need to do and process it in their own way. I do this all the time when I'm teaching students how to close read and process language within a text that they're reading. 6, use of example and non-examples of strategy application to text, and then multiple opportunities for students to respond to what is learned, which I think sometimes lacks, especially if a lab is super long. 8, monitoring, which is obviously something that we should all be doing. Ample guided practice, distributed over time that ensures students' mastery and maintenance of strategy application. And then number 10, opportunities for teacher and student reinforcement for meeting goals. All of these together serve as a way of differentiating leveled. So the key thing with science is that it needs to be leveled in a way that allows students to work to or work towards the goal of that lesson within the science classroom, even if it's complex, right? We can't just write off students because they don't necessarily come in with the foundational skills that you think that they need in order to process the science lab. And it shouldn't be watered down. What should happen, just like the article stated, is that with good teaching, they should be able to bridge, right? So what they know and then build up to the complex and rigorous standards of that lesson or of that lab. And they can if we actually instill in them things that they need. So as it states here, these practices offer many ways to modify secondary science curriculum to increase the success of students. Applying these skills in a science classroom will help increase the reading ability and comprehension of science literature. And I focus on reading because, like I said to you, at its core, science is about reading comprehension. Your ability to comprehend what is being asked, what is being implied, and also what, I guess, procedures and outcomes that are being targeted for any type of study or any type of lab that students are required to do. So the main key thing here is that if you focus on the reading ability of the student and their readiness to apply what they read, then you'll be more likely to see the success of the students within the lab or the science experiment or the science exams, because they at least have the basics and they're able to then comprehend. Half the time students don't even know what you're asking them to do because they don't have the foundational skills. So Part 3 of this lecture, just like previous ones, includes 2 video models, and they're at different levels. So one is at the high school level, it looks like, within a different education setting, and another one's in the 7th grade. So I hope that you enjoy these. Different from last week, I actually added the links to these videos at the bottom of the PowerPoint, just in case you're one of those people who are actually clicking on the PowerPoints and watching them from there, or going through the lecture from that point. I do hope that this helps you out. Sorry I went over 3 minutes. I hope that these resources really help you, especially if you are a science teacher. And wish you luck with your midterm project. I look forward to exploring them. Have a great week.